Today we began matrices, so we're going to start out by performing basic matrix operations. So we're going to add and subtract them, multiply by a scalar, and then solve matrix equations. So before we can do that, we need to go through some definitions. A matrix, first of all, is a rectangular array of variables or constants in rows and columns enclosed by brackets. So they're enclosed by brackets, and we have our rows and we have our columns of numbers. And it really does not look like a tic-tac-toe board. So our dimensions, and this is very significant, we're going to use this a lot. You need to know that the dimensions are the number of rows by the number of columns. Okay, so rows by columns, and I tell kids this is the only time you're not going to go in alphabetical order. R is going to come before C. So if I give you this matrix that's a 3 by 2, it means it has 3 rows of numbers with 2 columns of numbers. Okay, so that's what this says, 3 rows and 2 columns. I'm going to give you another matrix in just a minute. But elements, these are the values in the matrix. So if I give you this one here, this is not 3 rows and 2 columns because there's only 2 rows with 3 columns. So these are not equivalent, they are not equal. The entries again, or the elements, are just the numbers in the matrix. So we have the elements are 1 through 6, and then I show you here that the rows are 2 by 3. 2 rows by 3 columns. A square matrix is where the dimensions of the rows and the columns are equal. So we have a 2 by 2, a 3 by 3, a 4 by 4, and we could continue on. The zero matrix is when all the elements are 0. So I'll give you a square matrix. It's a 2 by 2, and all the elements are 0. And then I have 2 rules here. 2 matrices are equal if their dimensions are the same and the elements in the corresponding positions are equal. The first thing you will check is the dimensions, and if they are equal, then you can actually go on and set the corresponding positions equal. The second rule that I have here is when adding or subtracting matrices, the dimensions must be the same, otherwise it's not possible. You cannot add them. So we're going to look, first of all, you're going to look and determine the dimensions. Here we have 3 rows by 2 columns. Here we have 3 rows by 2 columns as well. So because those dimensions are equal and they're both 3 by 2s, we can add or subtract or perform the indicated operation with corresponding positions. So we take 2 plus negative 6. 2 plus negative 6 will give us negative 4. Then the corresponding position with the negative 1 is the 9. Negative 1 plus 9 is 8. We're going to go across and take that 3 plus the 7 in the middle rows, and that will give us 10. And then 7 plus a negative 11 will give us negative 4. We're on the bottom row. 14 plus negative 8 is 6. And negative 9 plus 17 is 8. And there's your matrix. That's what those two give you when you add them together. The second one's easier to see. We have a 2 by 2, 2 by 2, they're square. Because the dimensions are the same, we're going to go ahead and add corresponding positions. So this 3 and this 2 are corresponding, and I think I just said add, but really we're going to subtract. So we take the 3 minus 2 gives us a 1. The 3 minus 0 going across gives us 3. And then down for our second row, 9 minus a negative 3 gives you 12. And negative 5 minus 5 gives you negative 10. With the bottom example, we have a 1 row by 2 columns. The second one is a 2 by 2. Because these dimensions are not equal, then we cannot add them or subtract them. And in this case, we can't add them, so we say not possible. So always check those dimensions before you try to add or subtract. A scalar is a constant value that's being multiplied by a matrix. So we have like 4 would be a constant, 5 would be a constant, negative 1/3 is a constant. So scalar multiplication, if you have this constant, we're going to say it's k right now. But if it's outside a matrix, what it means is that you will distribute it to all the terms inside the matrix. And that's what this reads, k times a, k times b, k times c, and k times d. So we're going to practice using that scalar. This 5, remember, we're going to distribute it to everything inside the matrix. And when you distribute, you multiply. So we get that 5 times the 0 will give us 0. We're going to go across, or I'm going to go across. 5 times negative 6 is negative 30. And then 5 times 4 is 20. I'll do the bottom row. 5 times 1 is 5. 5 times negative 8 is negative 40. And 5 times 7 is 35. On the second one, I would encourage you, first of all, to make sure the dimensions are equal. And both of them do have equal dimensions. And then I would go ahead and multiply my scalar first. So when I multiply that scalar first, I take negative half times negative 8, which is 4. I'm going to go across. Negative 1 half times 0 is 0. And then I'll go to the second row. Negative 1 half of 2 is negative 1. Negative 1 half of negative 12 is 6. And then I'll do that bottom row. We get negative 3 and 7. Once I have that established, then I'm going to perform the indicated operation. And I'm just copying the matrix down. And then I'm going to write the answer up a little higher. So I'm going to add those. Remember to add corresponding positions, so I take the 4 in the first matrix plus the negative 4 in the second matrix to get 0. Going across, 0 plus 5 is 5. On the middle rows, negative 1 plus 6 is 5. 6 plus negative 8 is negative 2. Negative 3 plus negative 2 is negative 5. 7 plus 2 is 13, and then you're finished. Example 3, we actually have a matrix equation. So we have one matrix that equals another. Before you can solve it, check the dimensions. These are both square, and they're both 2 by 2, so the dimensions are equal. Once you have checked that, then you can set up your equations using these values. 4w equals 12. Make sure you set up that equation using corresponding positions. I have corresponding positions here, so I set up the equation negative 2x equals negative 12. Down in the bottom we have this one and this one here. Because they're equal and there's no variable, we don't need to do anything with them. It's just is another way to verify that those two matrices are equal. And then we'll go to that last one where we have 6 equals 2y. Once you have those equations, you're just going to solve them. To solve the first one, we divide by 4. And w is 3. The middle one we divide by negative 2. And x is 6. And the last one we divide by 2. And y is 3. On this second one, you have to be careful. You'll look at this and you'll think it's a 2 by 2, but it is not. These two, we use the word attached a lot, are attached by a negative and by a positive. So because they're attached, it makes it one line there. So we actually have 2 rows by 1 column. Same thing over here, 2 rows by 1 column. So to solve this, we go ahead and take that corresponding positions and set them equal. And our bottom one, 3x plus 5y equals 14. At this point, you should recognize that this is a system of equations, and we have solved these in that last unit. So to solve them, we're going to create opposite coefficients. Because these are already opposites right there, I'm going to choose to eliminate the y first, and I'll eliminate by multiplying the top one by 5 and the bottom one by that number, 4, and then I'm going to rewrite these equations. So I'll distribute the 5 through first. Sorry about the bell. And when I distribute the 5, you get 35x minus 20y equals 85. We distribute the 4 on the bottom equation to get 12x plus 20y equals 56. We go ahead and add these. These will be eliminated. We get 47x equals 141. We divide by 47 to solve for x, and we come out with x equals 3. Once you have that, we're going to go back into either the top equation or the bottom. I'm going to choose the bottom equation and replace the x with 3. And then solve it. We get 9 plus 5y equals 14. Subtract 9.
Homework.
You're left with 5y equals 5. And y will equal 1. And this is your solution. You can either write it like this individually, or because if you recognize it's a system, you can say that there is one solution located at 3, 1. I'll accept either of those answers. Okay, I have some steps on using a calculator, but you're probably going to be better off coming and seeing me and asking me how to store all this information in your matrix. Here's some basic steps, but again, come see me and I will help you guys learn, or help whoever needs learn how to input this information into your calculator. So your assignment is perform basic operations on matrices. Good luck.